this video is only going to answer question 1 of the 2-part question that was posed. Here's a graph of y equals x squared minus 20. This parabola is y equals x squared, vertical shift down 20. So this vertex is at 0, negative 20. And the line is the equation of y equals negative 6x plus 35. So the y-intercept is at plus 35 with a slope of negative 6. If you want to find the points of intersection, you have to solve this quadratic equation. I'll leave that to you, but you do get negative 11 and 5. And now here's the formula you want to use. At least if we're having the washer method, we want our washers perpendicular to the axis of revolution. Shell method, the shells would be parallel to the axis of revolution. And we want to use outer radius squared minus inner radius squared. The question is, what's an algebraic expression for the outer radius and for the inner radius? So for outer radius, that's the distance from the axis of revolution all the way to the line. And that's a vertical segment. So one way to get that distance is the y-coordinate at the top minus the y-coordinate at the bottom. So the y-coordinate at the top is always negative 6x plus 35. Minus the y-coordinate at the bottom, well, that's always a negative 35. So it looks to me like an expression for the outer radius is negative 6x plus 70. And in the formula, we have to square that. And by the way, our values of a and b are now, this is a, negative 11, 2, this is b, 5. We now have an expression for the outer radius, negative 6x plus 70. The quantity squared, make that an x. And now we want to find the inner radius, which is this little distance right here. And same deal, it's a vertical segment. So for the inner radius, it's the y-coordinate at the top, which is x squared minus 20, minus the y-coordinate at the bottom, which is always negative 35. Since we're squaring the results here, we could have subtracted in the other order, but it's a good idea to top minus bottom gives you the distance or the length of a vertical segment. So this is x squared plus 15. X squared plus 15. The quantity squared and dx. Now, if you had to actually figure this out by hand, you'd have to square this binomial, combine similar terms, find an antiderivative term by term, evaluate from negative 11 to 5, and multiply by pi. There you go. Hope that helped. And I will provide a link to this Desmos graph, which also has this integral set up. There you go.